This is a video illustrating the correlation procedure in SPSS. This is the SPSS data editor, and before proceeding further, you will note that this screen looks somewhat different from the version of SPSS that is available to you in the university computer labs. This is simply because this is an earlier version of SPSS, but the commands we will use in this version and in the version in the university computer labs are the same, as well as the output which these commands will produce. With these introductory comments behind us, let us begin the illustration. The data in this file are crime rates for the index crimes compiled and computed in the Uniform Crime Reports by the FBI for the year 2012 for all 50 states. There are 4 violent crimes: murder and non-negligent manslaughter, forcible rape, robbery, and aggravated assault. What we will do is to correlate each of these violent crimes with the others to see how they are related to each other. We begin on the command line with the Analyze command. We click on it, and from the pull-down menu, we note that one of the options is Correlate. We will be correlating 2 variables at a time. Hence, we will choose Bivariate Correlation. In the Bivariate Correlations window, we move the variables to be correlated from one panel to the next. In this case, we're going to move murder and non-negligent manslaughter, forcible rape, robbery, and aggravated assault. Notice that further down in the Bivariate Correlations window, we have choices for the correlation coefficients we want computed. In this illustration, we want the Pearson correlation coefficient. If we wanted either Kendall's tau or the Spearman, we could choose those as well. However, we have interval or scale variables in this illustration, so the Pearson correlation coefficient is the most powerful for this case. The tests of significance and the flagging of significant correlations will be explained in subsequent lectures. Notice there is an Options button on the window that we could click, and we could get additional data from this file, from this procedure. However, we have enough already to have SPSS do the correlations for us. So let us simply click the OK button and watch what happens. This output from the correlations command is called a correlation matrix. There are several parts of this matrix to which we should pay attention. To begin, notice there is a diagonal running from the top left cell down to the bottom right cell. Notice that the Pearson correlation in each of these cells is 1. Recall from a previous slide that 1 indicates perfect positive correlation. The reason each of these correlation coefficients is 1 is because in these cells, one variable is being correlated with itself. This will always be the case because each number in the first instance is being correlated with an equal and identical number in the second instance. Now let's look at the 6 cells, 1, 2, 3, 4, 5, 6, that are to the right and above the diagonal. These indicate the correlation coefficients for each of the variables, two at a time. So this correlation coefficient of minus 0.011 indicates that there is a negative correlation between murder and non-negligent manslaughter and forcible rape. The correlation 0.609 indicates a positive correlation between murder and robbery, and the correlation coefficient of 0.594 indicates a positive correlation between murder and non-negligent manslaughter. Notice there is a negative correlation between forcible rape and robbery, and a positive correlation between forcible rape and aggravated assault. Finally, there is a positive correlation between robbery and aggravated assault. Now let's look at the cells that are to the left and below the diagonal. Notice that the correlation coefficient in this bottom left cell is the same as the correlation coefficient in the top right cell. That's because we're correlating the same variables. In the bottom left cell, we've correlated murder and non-negligent manslaughter with aggravated assault, just as in the top right cell, we correlated murder and non-negligent manslaughter with aggravated assault. Notice that here we have robbery and murder correlated. Here we have robbery and murder correlated. Here we have murder and forcible rape correlated. Here we have murder and forcible rape correlated. Here we have robbery correlated with rape. Here we have aggravated assault correlated with rape. The point of showing the similarities, the identities between the cells to the right and above the diagonal and to the left below the diagonal simply indicates that they are the same correlations presented in a matrix structure. This means that when you are analyzing these correlation coefficients, you need only pay attention to a particular range of cells. This pattern, wherein the correlation coefficients to the right and above the diagonal and to the left and below the diagonal match each other, will be true regardless of how small or how large the correlation matrix is. Notice that across each row of the matrix there is a second row, sig two-tailed, and a third row, n. For the moment, let's ignore the sig row. N refers to the number of pairs of variables that have been correlated. In this illustration, we have data for all 50 states. So we were able to correlate for all 50 states the correlation coefficient for murder and rape, for all 50 states for murder and robbery, for all 50 states for murder and aggravated assault. Were there any missing states, this number would be reduced by the number of missing states. But this number, recall, is the number of pairs of cases being correlated. This concludes the video on correlation. As you can see, it's a relatively simple, straightforward procedure in SPSS. All you have to do is click on the correlation command, the bivariate command, indicate the variables you want correlated. Remember, the procedure will correlate two variables at a time, and then click OK, and you will get output in the form of a correlation matrix, and you can consult this video for interpreting or analyzing the data in the correlation matrix.